the scope has one window. You can see one triangle here. You can connect current here. But then if you want to see the voltage here, you have to have another scope. Similarly, we are interested in seeing the voltage across the inductor as well. It has to, average voltage has to be 0. So we see that. Now this we will check the voltage. It will show the voltage across the inductor, and this will show the current through the inductor. This will show the output voltage. Now we have 3 measurements to be seen, and we have one scope. Either you can have individual scopes, or it is a good practice to use multiple window from a same scope, for which what you have to do is double click the scope. The scope window will open. This gear wheel, which corresponds to settings, you click that. Number of input ports, you can change it into the number you want. Here I need 3. Now next is the layout. This scope maximum allows 16 types of 16 different sub scopes. I need 3. It can be side by side, or it can be one below the other, and I would be preferring one below the other. So I am taking, I need 3 ports, so 3. Before you click apply, go to logging window. If it is checked, uncheck this. I will explain in class why we should do that. Go back to main window. Once you have selected 3 and once you have selected the layout, click apply and click OK. Now you can see 3 subplots have come here. Not only that, 3 triangle marks have come here as well. Now you can see the graph here. The background is black, which is not good. Maybe it's good for seeing, but once you are preparing the graph to your reports for printing and all, this doesn't look good at all. And it will consume a lot of ink if you are using this screen to print. So it's better to change the background to white, for which there is a small downwards arrow shown here. It may be slightly different in these window you use depending on the versions of the MATLAB you use, but still click that. There is a paint bucket kind of thing you can see. Click that. Now a window like this will come up. So the top 3, this is common for all the graphs here. 3 subplots are here. Figure color is black, which has to be changed to white. Okay. Axis color, let it be black. Now once you click apply, you see axis is black. That means only this has been changed to white. Change this as well. Now the background window has also been background color also has been changed to white, and this is what we wanted. Now active display, there are 3 displays, 1, 2 and 3. The first one, before we do that, let's connect it. First one is the voltage across the inductor. We can label it by double click this, voltage across the inductor. Second one is current through the inductor, and the third one is the output voltage. Output voltage VO. Now go back to the same paint bucket thing. So active display 1, by default the display is in black background with yellow foreground, yellow color. But on white background, if I plot yellow color, that will not be good, looking good, and the contrast is not also proper. So what you have to do is change the line width to 1 and apply a contrasting color. Avoid pale light colors, use dark colors. A good combination, good color choice would be black. You can use red, dark blue, dark green, dark brown, or anything of that kind. Something which is contrasting, you can use it. Click apply. Now the first window, active window 1, will show the waveform of inductor voltage across inductor in red color. Now moving on to 2, which is current. Again, change the line thickness to 1. Let it be blue color. That should be fine. So channel 3, time width change to 1. Red and blue is already taken. You can still use the same color. It's absolutely fine. You can use black if you wish to. I would stick to green. Click apply. And then click OK. Now we have configured our scope window. This is essential step to be done, because most of the, by default, the background is black, and take screenshots and put it in the report. It doesn't look good, and it will not be readable to me. It will not be readable to you, and it will consume a lot of cleaning. Prevent that. You do this step first before you start your simulation. Now we have connected everything. What is missing is the gate signals to the IGBT. So for that, go back to the sources window. You will get pulse generator. This is what we want. Drag and drop it here. Double click that, you will see some settings. Let it be. It should be time based only. Amplitude is 1 is fine. It is logical value, 1 or 10 or 100, whatever you want you can give. 1 will serve the purpose. But this is what is to be changed. By default it is 10 seconds, but we cannot use a frequency of 0.1 Hertz to fire a switched mode power supply. So I will change it to the switching frequency what we have. Let me have 50 kilohertz as the switching frequency. So 1 by 50,000 is the periods. Pulse width, this is the duty ratio D, which in turn controls the output voltage. So let me put it as 40% or 60%. Any value you can put, but it should not be very close to 90, or it should not be very small, such as 3 or 4%. So 60, let me put 60. So 60% of the input. If the input is 100 volt, output would be 60 volt. That's what it means. There is no delay. Just click apply and OK, and connect it to the gate signal. Now I have to connect. Yeah, this is 100 volt. That's fine. Inductor value, capacitor value, and load resistance has been already set. Now we are done for simulation. But before we do, come to this power GUI block. You double click that, and simulation type. There are 3 types: continuous, discrete, and phasor. Remember, whenever you are using power electronic circuits, these are non-linear circuits, and hence we cannot use continuous. It has to be discrete. It may work in continuous mode, but in complex circuits you may run into problems. But so it's a good practice to change it to discrete, and even for very small, such simple simulations such as buck converter. Now the solver type, you can select so many things, even additional things are there, but let it be the default value. What is to be changed is the simulation type, sample time, 50 microsecond. And what was our switching frequency? It was 50 kilohertz, which means 20 microsecond is the time for one cycle. It is a good practice to take at least 20 samples in one cycle to get the correct waveform. So let me put it as 2.5 microsecond. No, not 2.5. Let it be 2 microseconds. Let it be 2 microseconds. So 20 microsecond is the switching sample. So switching period, once we are using 2 microsecond as the sampling time, you will have 10 samples for each switching cycle. Let's see if this is enough or not. Apply and OK. So this is very straightforward. If you lower switching frequency, we will discuss it later. Now once everything is done, the star mark you see here, the asterisks here, this means some changes have been done to this and it has not been saved. So you just click save it. Once it is saved, that star mark vanishes, now which means the system is saved and it is ready to run the simulation.